we're gonna learn about, thank you. We're gonna learn about how do our body maintaining the blood pressure, okay? Because that is crucial for the process of living. The metabolism in our cells is needing oxygen, and oxygen is distributing through our blood. And how does our body maintaining the blood pressure is really crucial once again. Okay, reminder that our cardiovascular system, there is heart, blood vessels, and the blood. What is the function of the heart? Is to pump something, pumping the blood. Okay, it's like the factory that make cars, and then the blood vessels is the road, and the blood is the people in the car. Okay, so the blood vessels is channels for directing and distributing the blood, and the blood itself transport medium for materials such as oxygen, carbon dioxide, nutrients, waste substances, everything that you guys need, the blood transported. Everything that you guys don't need anymore, your blood taking it away from your body. Okay, so that is the most basic function of our cardiovascular system. And right after that, in this section, we're gonna learn specifically about blood. And during rest, you guys have to know there is differences for the distribution of our blood in our body during rest and during fight or flight response. Okay, just like everyone already knows, we got the autonomous nervous system. We can't control it. It's involuntary, you know. They got two states, rest and digest and fight or flight. Okay, and here I'm talking about the resting. What is happening in your organ when you are at rest? Okay, so the blood is going through your lung 100% because it needs to exchange the oxygen and carbon dioxide in and outside of our body. Inhale and exhale, you know, so it needs to be 100% go through the lungs. But you see there is this list of organ here, the digestive, we got liver, and then renal, or what is ginjal in English? I forgot. Yeah, whatever it is. And we got the skin, brain, and then the myocardial, and then the muscle, bone, and etc. Okay, you guys have to remember this because this is important. Especially you have to remember the big portion of our perfusion. So the blood at rest is bigger at the digestive system. Okay, and then when we are in a state of flight or flight, it's going to move to the functional organ to help us going through the challenge, you know. So the blood will going to be much bigger in the muscle, in the heart, and etc. Okay, you have to remember this: 21% in the digestive, and we got 20% in our renal, and then in our muscle about 50%.
เขาเรียนหรือยัง
Aina, can you, okay, please. Okay, good. Okay, next. To maintain homeostasis, reconditioned organs receive blood flow in excess of their own needs. Okay, each of the organ has different percentage of blood during rest. Okay, and what is blood flow rate? Atau dalam bahasa Indonesia laju apa ya? laju aliran darah gitu ya, through the vessels depending on the pressure gradient and vascular resistance. Oke, jadi kan udah kecampur bahasa Indonesia. So the blood flow rate is determined from the pressure gradient and the vascular resistance. Or you can see this is the F and P. And after that, R. The P is the gradient or the pressure gradient. Okay, what is the pressure gradient? So you see this is the P1. This is at the starting point, and the end of the blood vessels is P2. Okay, the difference of the pressure between P1 and P2 is what we call pressure gradient. Now let's see, the note F is flow rate through a vessel, and P is for pressure gradient, and R for blood vessels resistance.
Nan yang haram.
F is rate through vessel, P is for pressure gradient, blood vessels resistance. Nurhanan. Nurhanan, can you please mute your audio because I can't focus right now? Can anyone tell? Okay, good. Okay, let me read this one. The rate of blood flow through a vessel is directly proportional to the pressure gradient and inversely proportional to vascular resistance. So when the pressure gradient is bigger, then the blood flow is going to be bigger too. And when the vascular resistance is smaller, the blood flow will be bigger. That's it, you know. I don't know how to explain this. Okay, first we'll learn about pressure gradient, okay? Once again, the pressure gradient is the pressure difference between the beginning and the end of a blood vessel, flowing from an area with higher pressure. Okay, this is the higher pressure. Where is my laser? Okay. This point is higher than this one. That's called the pressure gradient. And you see, this one is 90 and this one is 10. The difference is 80. The 80 is what we call the pressure gradient. That's simple, okay? Pressure is higher at the
Sorry,
beginning.
Kak. I think your PowerPoint is stuck, Kak. We're still in the slide 11.
Okay, wait a minute. Maybe because my signals is bad here. Let me change it to my,
Yeah, now in the fourth slide.
okay. Thank you, Sultan.
Okay, Kak.
Can you see my slide is moving?
Still in the 4, Kak.
Still in the 4. Okay. Okay.
Yeah, now already, Kak.
I think there is something wrong with my laptop and I can't make it full screen right now. I don't know what is wrong, but I hope you guys can still see the PowerPoint clear enough, you know? Okay. So once again, the pressure gradient is when the pressure is higher at the beginning and at the end is going to be lower because there is resistance. This one you have to remember it, okay? Because there is resistance. Why is the pressure is higher at the beginning than at the end of the vessel? Because it has resistance. What is resistance? We're gonna learn about it in the next slide, okay? So this is the example of our upper extremity where you can see there is a lot of the name of the artery. You can see the proximal one. This is the right subclavian, and then we got the axilla. The more it's far from the heart, the more resistance it gets, and the pressure gradient is going to be lower at the end. So the pressure gradient here is bigger than the one that is here, okay? So the second one, that the biggest factor for your blood flow is the resistance vascular, okay? That is the obstacle or resistance to blood flow through a vessel. The challenge that the blood has to go through, you know, that's what we call resistance. So why is there the resistance? That is because something we call friction, or in Indonesia we call that gesekan. So the friction between a moving fluid and a stationary vascular wall. Okay, so the key for resistance vascular is the friction. Now, this is the factors affecting vascular resistance. So we got three factors: vessel radius, vessel length, and viscosity. And radius and the length is about the vessel, and the viscosity is about the blood, okay? So the vessel radius, or the diameter of the blood, the diameter of the vessels, I mean, inversely proportional. It means that the bigger the radius is, the smaller the resistance, okay? When it says directly proportional, it means the greater, the longer the length is, it's going to be greater resistance because the friction is bigger and the viscosity too, okay? This is the formula you can see here. And then we got vessel radius, or the diameter of the vessels. Fluid flows more easily through the large vessels than small vessels. Why? Why fluid flows more easily? Because when the vessels is larger, the smaller the friction is, okay? A given volume of blood comes in contact with a much larger surface area in a vessel with a small one, okay, than in a vessel with a large one. That's why the fluid flows more easily through the large vessels than small vessels. This is the main determinant of resistance to flow is the radius of the vessels, okay? You have to remember, we got the resistance and then we got the pressure gradient, okay? The resistance got three other factor: the vessel radius, the length of it, and the viscosity. And the most important one is the vessel radius. That's the point. Okay, and we got the how does our body maintaining the blood pressure? Mainly through the diameter. How does our body changing the diameter of the blood vessels, or what we call vasoconstriction and vasodilatation? Okay, this is the factor that triggering the vasoconstriction of our blood vessels. Okay, you see, this is the artery. It got three layers, and the thickest one is, we call that tunica intima or media. I forgot about that. But remember that we have muscle, smooth muscle on our blood vessels, that making, when it's contracted, it will make the diameter getting smaller, okay, what we call vasoconstriction. It increases contraction of circular smooth muscle in the walls of arterioles, causing increased resistance and decreased flow. So this is what you got when you have hypotension. It's happened the vasodilatation, okay? And then you give the patient some drug that works to the muscle that make it contracted, so the vessels getting smaller or vasoconstriction and making the blood pressure higher than before, okay? Other than drugs, it may be about the myogenic activity or the amount of oxygen that your body detects. We have the receptor on our body that detecting how much concentration of oxygen in our body is. So when the concentration of the oxygen is too low, we're gonna get our respiratory rate will be increased and the blood vessels will be constricted, you know, to move the blood adequately, you know, to move the blood until the most peripheral part of your body, okay? And we got here the other side, the cause of hypotension, because there is vasodilatation, same cause, but it's when the oxygen is decreased, when the carbon dioxide is increased. It's some type of the opposite of this one, okay? Second one is vessel length. At a fixed radius, the greater it is long vessels, the greater it is the surface area. So this is the artery 1 and this is artery 2. You see this is longer than this one. So the resistance in here is going to be much bigger because the surface area here that make the friction between the blood to the endothelial cell here is bigger, okay? That's the key. And then viscosity, or also known as, viscosity. Atau bahasa Indonesianya apa ya? Kekentalan daripada darah, ya. Viscosity, it refers to the friction that forms between liquid molecules when they slide against each other when the liquid falls, okay? When you got too much lipid in your blood, too much glucose, the viscosity is going to be much bigger. And the bigger the viscosity is, the bigger the resistance to flow. Okay, remember the viscosity and the length is directly the same, has the same impact as the resistance, but not about the radius. Okay, the radius is the opposite. The smaller the radius is, the higher the resistance. Okay. This is the same thing as I said before. And we have the puzzles, how to pronounce this thing. Okay, let's just forget about how to pronounce that. I'm just going to read this thing. Factors that influence the speed of flow through a vessel are integrated into the Poisson's law, which is a law that expresses the relationship between blood pressure, blood vessel radius, viscosity, and the effect of blood vessels have on blood flow. So it's like making the synthesis or the conclusion about what we've learned today about the blood flow. Okay, this is the formula. The main method for controlling blood flow is through contraction and relaxation. Remember this. The main method for controlling blood flow is through contraction and relaxation. Not the viscosity, not the length. It's about the muscle in the blood vessel. Okay? Thank you. Anyone have any question? If you don't have any question, I will ask you questions. been waiting my whole life to ask someone question because lately everyone asking me one. Okay. Which one is gonna end? Maria Nantabut, can you hear me?
Yes, Kak.
Okay, sister, I will ask you a question. Do you remember what percentage of blood is circulated to the renal? At rest.
Kak, can you repeat the question again?
What percentage of blood is circulated to the renal at rest?
I don't know, Kak.
Okay. What you know? What do you know? What have you learned?
I know about the formula of blood flow rate.
What is it?
F is the P per R.
If you can speak English, you can speak Indo, but I can't understand Thailand. Can you repeat it one more time, Maria? The formula?
Can I say about the factor effective vascular resistance? Is divide 3. The first is
Okay.
radius, the second length, and the last is viscosity.
Okay, thank you, Maria. And what is the most important one from that three? Saifuddin?
Okay, Kak, thank you.
Okay, thank you. Saifuddin, Maria mentioned that there is three factor that controlling our resistance. Can you say or can you mention it to me? What is the most important one?
Again, my speaker have some problem.
What, you want me to repeat the question? Okay. What is the most important one from the three factor that Maria already mentioned before about our vascular resistance?
About
About
increase oxygen.
I can't say it's wrong, but it's not the answer. What I want is from the three that Maria already mentioned. The length, the radius, and the viscosity. Which one is the most important one?
Oh. Length.
One. Tetot. Okay. Anyone else can answer the question?
Viscosity, Kak.
The radius, Kak. Oh,
Yep, the radius. The radius is the key for our vascular resistance. And our vascular resistance is the key to maintaining the blood pressure. Okay? Keep that in mind because our body has muscles in the blood vessel. Okay? The smooth muscle around it. Okay? When we are no. Okay. It calls vasoconstriction and vasodilation. Constriction is good, making the radius is smaller, and the dilatation is the opposite. Okay. One Hafiz, can you hear me? I guess he can hear me. Naki,
Iya, Kak.
okay. Naki, tadi berapa persen darah yang dialirkan ke ginjal?
Sorry, Kak, putus-putus.
Putus-putus. Nih. Berapa persen perfusi ginjal pada saat istirahat?
20?
Yep.
Okay.
Do you know about digestive one? The percentage of our digestive at rest?
I think it's similar, so 21.
Yep, you got it
It-
right. Okay, thank you, Nak.
Oke, Kak.
Balkis?
Iya, Kak.
Okay. Balkis? Wait. Why is the pressure higher at the beginning than at the end of a vessel?
Maybe because of the radius, Kak, and at the resistance of the vascular.
Yeah. The resistance of the vascular is the right one. Okay. The radius is part of the resistance. But the answer why is the pressure is higher at the beginning than at the end if it's just the resistance. Okay. You don't need to mention about the radius.
Oke, Kak.
Okay, I think that's all I can say for tonight. And good night. I hope you guys have a good sleep because I'm not anymore. And thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Terima kasih, Kak.
Thank you,
Kak
Kak.
Mika.
Thank you, Kak.